Dear students, in this class I am going to explain briefly about a few important questions. Actually these are very short answer questions asking for 2 marks in the public exam. Okay, let us start. First question, what are Ldpe and Hdpe? Here how they are formed. First Ldpe. Ldpe means low density polyethylene. Just already we have discussed formation of polyethylene in different cases. Just in the previous lecture also I explained you under addition polymerization how polyethylene is obtained. Same thing. Here you see ethene, a number of ethene molecules undergo polymerization to give polyethylene. But the formation of polyethylene can be happened in two different ways. One is in the presence of oxygen at around 500 Kelvin temperature, 2000 atmospheric pressure. Or sometimes it can also be obtained by using a catalyst called Ziegler-Natta catalyst. So if the polyethylene is obtained in the presence of oxygen and certain temperature and certain pressure, then it is said to be low density polyethylene. If the polyethylene is obtained in the presence of Ziegler-Natta catalyst, then it is called high density polyethylene. That's all, very simple. Whatever is there on the board, you note it down and write in the exam. That's it. This is the answer for this. Here, what is Ziegler-Natta catalyst? This is one of the very important 2 marks questions. I am not going to explain this part separately. Here the question will be like this. What is Ziegler-Natta catalyst? Where it is used? Ziegler-Natta catalyst is triethyl aluminum plus titanium tetrachloride. It is a mixture of triethyl. Here C2H5 is there. C2H5 is an ethyl group. There are 3 ethyl groups. So triethyl aluminum plus titanium tetrachloride. Mixture of these two is called Ziegler-Natta catalyst. It is extensively used in the preparation of high density polyethylene. Next, what is the Dacron? How it is obtained? Sorry, here some words are missing. Note down. What is Dacron? How is it obtained? So Dacron is a polyester. Its monomers are ethylene glycol and terephthalic acid. Ethylene glycol and terephthalic acid. Ethylene glycol formula, ethene formula you know, CH2 double bond CH2. Now here you see, here there is no double bond. It's a CH2 single bond CH2 and 2 hydroxyl groups are there before and after, means in the beginning and at the ending. So CH2OH, CH2OH, this is called ethylene glycol, and terephthalic acid. Here you can observe one benzene ring, and the opposite sides of that benzene ring there are 2 carboxylic groups, COOH, COOH. This is called terephthalic acid. These are the 2 monomers. It is an example for condensation polymerization. In the previous lecture, we have discussed the example for condensation polymerization, as there we have taken nylon 6,6. So this is also one of the examples for condensation polymerization, that is formation of Dacron. Now how the condensation takes place? See, very simple. Here OH groups are there now in the beginning and at the ending. So from the OH group, 1 hydrogen you have to remove, and from OH groups, from the carboxylic acids, remove OH groups from both sides. Then condense both the parts and you will get the product. Very simple. If you remove H from this side, then you will get only O here. O, CH2, CH2. O, remove H, then you will get only O. Next from COH group, remove OH, then you will have only OC or CO, OC, benzene ring. Next CO, this OH should be removed. That means from COOH groups you have to remove OH groups, and from OH groups you have to remove hydrogens. Then upon condensation we will get a Dacron or polyester. So here the byproduct is water. We no need to write. If you want, you can write. Next question, what is a biodegradable polymer? Give an example. Biodegradable polymer means there are a few polymers or few plastics which cannot be degraded. Means if we throw it out, they will be lasting for years, hundreds and thousands of years. They cause us a very severe environmental pollution. But there are few polymers which are very helpful to the nature, means they are eco-friendly. After a few months or few days, they will be degraded or decomposed and mix up into the earth. So there will be no harm with such type of polymers. The polymers which decomposes itself or themselves in the biological system are called biodegradable polymers. See here, a polymer which decomposes itself in the biological system is called biodegradable polymer. Here D is missing. So example PHBV. So this is a very simple answer. This carries 2 marks. Next come to next question. What is a PHBV? How is it useful to man? What is PHBV? PHBV is a biodegradable polymer. Its full form is poly beta hydroxybutyrate co beta hydroxy valerate. Okay, PHBV, poly beta hydroxy butyrate co beta hydroxy valerate. This is the full form of PHBV, and its monomers. No need to write in the exam. If you want, you can write. Very simple. 3-hydroxybutanoic acid plus 3-hydroxypentanoic acid. Buta means 4, butanoic acid, penta means 5. 3-hydroxybutanoic acid, 3-hydroxypentanoic acid. These are the monomers. Next, what are the uses of PHBV? PHBV is extensively used in special packings. So few packings which are eco-friendly packings, they do not cause any environmental pollution. And it is used to make orthopedic devices. Certain orthopedic devices are made with PHBV polymers. Next, some controlled release of drugs. Some types of capsules, the outer body of the capsule is made up of biodegradable polymers. When they are consumed, they will be easily degraded after reaching to our stomach. So they releases the drug very easily. So controlled release of drugs, certain packings are made with PHBV. Okay, dear students, go through these questions properly. These are all very important questions for 2 marks. We'll meet in the next lecture. Bye. Thank you.